Hi friend, this is a Dallas Rangemaster. It's a treble booster effect. I really love this circuit. It's really a lot of fun. I'm going to show you how I build one so that you can too. If that sounds good, stick with me. This is a schematic of the Dallas Rangemaster. You can see that there's not a lot of components. It's very, very simple effect. In fact, if you open one up, it's kind of like a bag of chips, mostly air. You know, I really don't like the introduction things that happen on every episode of everybody you see on YouTube, but there's a few things we should cover. A lot of people get into buying printed circuit boards that are already made and ordering kits from online. That's always felt like playing Legos to me. They give you the parts and you put them together. Let's not rely on other people on this build. Let's just do it all ourselves from the beginning to the end. We're going to make a schematic. We're going to make some modifications to it. We're going to lay out a printed circuit board. We're going to prepare the enclosure. We're going to make a shopping list and get all the components. Hopefully everything comes at once and we'll be able to put it together all in one day instead of looking at a printed circuit board and saying, now I gotta wait for a part. We'll work on that. We'll have a shopping list all ready to go. Okay, first things first, let's get you the applications you need on your computer so that you could do these layouts. First, we are going to go to Autodesk.com, right here, Products Eagle free download. It's a free version. It's limited, but it's more than what we need for now. You would have to grow a lot and make a lot of money before you actually have to start paying for Eagle. 2 signal layers is what we're going to use. It's a top and bottom layer. We'll understand later. So go ahead. Go to this website and download it for Windows, Mac, or Linux, whatever you have. You will have to register an account and give them an email address to set it up. But just go ahead and we're ready for the next step. Our next step is we're going to download a couple libraries to put into Eagle that we have just downloaded. These are our components and parts, and they're already sort of available with Eagle. But these will make our lives a lot easier by having the components we need without having to sift through a ton of other items just to get one resistor. So let's go to madbeanpedals.com. Now you're going to have to register an account with Madbean Pedals or you will not see the members area. And that's where the library is that we need. See right here, it's CADsoft Eagle Resources. Click on that. You're going to go down to MBP 2017 V3. It's the library release. Now, Madbean's an awesome website. You can get all kinds of information. You could ask questions. You can get the library that we're going to download. He also has a service where he sells printed circuit boards. He also has discontinued ones that you could print yourself. It's just a great place to check out. madbeanpedals.com. We're going to go to the CADsoft Eagle Resources, MBP 2017 V3 library, and we're going to download that. There it is. As you can see, I already have it downloaded. Twice, it looks like. So we're going to close that out and we're going to open up our libraries, which is on Windows in your documents /Eagle/libraries. On the Mac, it's pretty much the same. It's under your username, documents, Eagle, libraries. And all you do is you drop that whole folder that you just downloaded and unzipped right into there. It's right here. You can see all the other items that are included in the folder, and that's it. Oh, we're going to need one more. Okay, I want you to go to this site here, homespuneffects.com/resources. It's a real fancy page, don't get excited. Hit this homespun.lbr, but don't left click. Make sure you right click and save link content as. Just like on the Mad Bean Petals library, you're going to put this in the same place, the same folder. Okay, we should be ready to go. One thing I like to do is print out a copy of the circuit diagram. That way you could check off all the components and all the traces that we're going to add to the circuit. I always think that's a good idea. This one's not so difficult that you can't look back and forth, but when you get into more complex circuits, it's going to make more sense. Okay, we're going to open up Eagle and get started. We're going to go into our projects here and make a new project. We're going to call it NPN Rangemaster. First thing we're going to do is make sure that little green light is lit up right there. That means that project is open and we're using it. Then we're going to click New Schematic. All right. First thing we're going to do is we're going to modify the circuit so that it uses an NPN transistor instead of the PNP of the original. What that's going to do is it's going to allow us to have a little bit easier time with using power supplies with other pedals. If you plugged in a center negative power supply to the circuit the wrong way, it's just going to short out. You're going to have the case will be the positive instead of the ground. All right, so let's get started here. We're going to add a component, and you're going to see what the first problem is when you first run Eagle. Let's open our library manager. You'll see what's available is just the ones from that come stock with Eagle. If you have these in your in-use or in-design, go to in-use and select them all and just click this remove button right here. It's going to make our lives easier so you don't have to sort through all these. Look how many there are. And they are useful at times. But what we're going to do is browse to where we dropped those two libraries that we downloaded, and we're going to select them and open them. And when it says in use, you'll see that they're not available. So we're going to go back to our control panel window and see this little dot right here. It's not lit up, and neither are any of these. So if you right click this, you could hit use all, and you'll notice they're all lit up now, and Homespun is lit up. We could go back to our schematic, hit our library manager. Now these are all available. Homespun's there, and all the Mad Bean pedal libraries are there. Everything should be available here now, and it is. It's very important. So first thing we're going to do is work on our power supply. We're going to take a 9-volt power supply, and as you see, we're just going to, if you right click, it rotates it. Let's just put it this way for now. And I'm just going to go through a few things here. We're going to put a film capacitor in here. This will help filter out any ripple in the power supply. We're going to put a electrolytic cap in here, just kind of doubling up. And I use the 502 because it's the right size for what I do. And since we flipped the polarity, we also have to flip the polarity of the electrolytic capacitors because they are polarized. All right, we are going to add a light-emitting diode to this. This is the one I use because I like how it's laid out there. We're going to put it here. Oh, we're also going to put in some power supply reverse polarity protection. If you plug in a center positive power supply into this, it'll just short the power supply. And if you have a good one, it'll just trip its fuse instead of blowing up your pedal. I find that's important. I've done it before. All right, we also need a couple of resistors. I like these ones here because they're the right size for 1/4 watt resistors. We're going to put one here and one here. All right, now let's net all these together so that they're ready to go. I'm going to make it a little bit bigger. Let's move these down first. All right, we're going to choose net. That gives you your connections between components. And we're just going to connect all these directly to the power rail. Let me move that down a little bit more. There we go. Net. And this one's going to go to here. And I'm going to switch these ones. Since they don't have a value yet. And all these are going to directly connect to a ground. So we're going to choose this one and put it right here. Always do that. Okay. This one does not get connected to ground. Okay. All right, now we're going to add a potentiometer. We're going to choose, this is going to be a small build, so we're going to use the 9mm. Let's see which one we want here. I like that one. I like this one. And we're going to put it right here. Now this one is going to connect from the power. And we won't connect anything else to it yet until we get all this power supply. We're going to have to give a value to each one of these components. This power supply filter is going to be 100 nanofarads. I always try to keep the conventions the same. Capital F for farad. This one's going to be 47 microfarads. There's no mu, the Greek letter mu, on my keyboard, so I just use a lowercase u for micro. This is going to be 1N4001. Oops, 4001. This one is going to be 470 kiloohms. This is going to be 4.7 kiloohms. And this potentiometer, we're going to make that a 10 kiloohm audio taper. I always mark audio or B for linear. Audio it is. We're also going to name this one. These ones, as you see, this, the capacitor 1, capacitor 2, diode 2, should be, and we have diode 1. They're all named automatically as you place them. But this one we're going to name, instead of potentiometer 1, we're going to name it boost. Just so we know, it'll write it on the PCB when we get it manufactured. And if you have more than one, you'll know which one goes where. All right. Now, here's where we get into the rest of the circuit. We're going to go down to transistor and pick this one first. We're going to go to germanium transistors, NPN. Let's see which one we want. This one. This is going to go right here. And we're going to give this one a value of 2N388. That's the one I like. It works nice. It's real smooth. And we're going to connect that to the base of this germanium transistor. All right. Now we're going to go over here and we're going to get our jacks, and we're going to pick a mono one with pads like this. This will be our input. We're going to put it here. And here's the tip, and here's the sleeve. The sleeve is always grounded. And here's a few more modifications we're going to make to the circuit. We're going to choose this resistor. We're going to put this here. We're going to put another resistor here. We're going to pick a film capacitor here. All right. This one's going to set the impedance, the input impedance of the pedal. So we're going to make that rather high. We're going to give it a 1 megohm value. This one's going to set the bias of the transistor along with this one here. We're going to give that a 68K value. Oh, this is the wrong capacitor. We're going to trash that one right here. Now we're going to net these together. Now this is the secret of the treble booster. This is a high pass filter and it really cuts out a lot of bass. So we're going to give this the original value at first. That's 0.005 microfarads. We don't need to call it microfarads. We can make it nanofarads and just move it to 5 nanofarads instead. Makes it easier to shop for, actually. And this is going to net to the base of this germanium transistor. Now we're also going to need to put a resistor on this emitter. We'll add that here. Whoops. Connect it up. We're going to give that a value of 3.9K. And we're also going to add a bypass capacitor to this. This is going to be an electrolytic, so we have to make sure it's flipped according to the NPN instead of the original circuit. This is going to be 47 microfarads. All right, and we're just going to connect that. Let me move this down a little smidgen so I could connect it in the middle here to there. Now all these are going to get connected to ground, so I'm going to do that now. Let's get a ground here, put that here, connect it here, and yes. All right, we're almost done with this circuit actually. This collector actually connects to this boost. And basically what that does is it changes the power that's getting from the 9-volt supply to the collector. So what we need to do is make our output. This is going to be film capacitor. Let's give that a value. 10 nanofarads. That's a little low. It cuts out some base, but it's already been cut out here at the beginning. And we're going to go to put a resistor in on the output side as well. We're going to call this 1 meg as well as the output resistor is going to be the same as the input resistor. Let's see, we're going to net these together. This also goes to ground. This is grounded here, but what we have to do is we have to have a ground with a lug on it. So we're going to go back to Homespun. We're going to pick ground with a T. That means it has the solder pad. And we're just going to connect that right to where the ground is. Technically, we could just use that one, but I like to have one like this so that it's just easier to follow. Now what we got to do is put our output jacks. Let me see, we use this one. Nope, this one. That will go here. Need a little bit more room. Let's change that so it's facing. We're going to mirror it, and then we're going to flip it. There. That way the sleeve is easier to connect to ground. All right. The only thing we didn't add is a solder pad to the bottom of the... We're going to grab one of these with a label on it. We're going to put this pin right here, and we're going to label that. We're going to name that LED minus. We're going to have, that'll be the ground to the LED to turn it on when we need it. All right. I believe we're done with our schematic, but what I like to do is take the move, and I like to make everything as compact as possible. I make only the net's real short. And I get everything equal. Try to move all these over without overlapping. And the reason is, I'll show you when I get it done here. Oh, let's delete all those. I just like to hit this button right here so it's as big as possible so it's easier to see. I can print it out and it's nice size and it's just nicer to look at once you clean it all up. I could probably get these smaller by moving this over like this, getting this out of the way, and then bringing everything up. You do a trick like you group all these. Then you hit move, right click it, and you hit move group, and you can move the whole thing up. And now when you hit this button here, zoom to fit, it's a little bit bigger, a little bit nicer. But we're done with the schematic right now. Oh, there's one more modification. Since it's a germanium transistor that we're using, it's supposedly very susceptible to temperature changes. So we're going to put a germanium diode reverse biased in there to help to overcome some of that. So let's try going over here. We're going to get a diode. Let's see, this one, let's go with this one. And kind of didn't leave ourselves enough room here. So we will move these out of the way a little bit. Put this here. And net this in right here. So we're going to give this a value of 1N34A. That'll be a nice germanium diode to use in that situation. And we are done with our schematic. Okay, there's one last thing we have to do to make sure this schematic is complete, and that is to run an electrical rules check. We're going to click this and we will see that there are two problems. J1 has no value. So let's click on value and we'll give it one. We'll call this the in since it's the input jack, and we'll call this one out since it's the output jack. That's clear, and we will run that check again. And if you look down here, it says ERC, no errors or warnings. Everything's fine. So we can go ahead and we can save this. And that is it for today. Next time we're going to lay out a printed circuit board and submit it for manufacture. So if that sounds good to you, get with me next time. Do me a favor and hit the like button. Give me a subscribe so that you'll know when the next episode's coming up, and we'll finish this thing up soon enough. Hey, thanks for stopping by. I really appreciate it. Hello, friend. That was my first YouTube video. So let me know how I did down in the comments. If you have any questions, criticisms, anything like that, that'd be fine. I'd like to take this time to let you know one of my favorite YouTube channels. That's Uncle Doug. He's just inspiring to me, and he's a good dude. I think you should check him out. Uncle Doug. Hey, I'll talk to you soon. Thanks.